Okay, welcome to the time and location topic. Today I'm going to start off doing the time and time differences part of the syllabus dot points. There's not many. This is all there is for time and time differences, and then there's another section with positions on the Earth's surface, which I'll do in another video. But if we start with time and time differences, the dot points are to convert between seconds, minutes, and hours. So that's very straightforward. You should already have a decent idea of how to do that, but I'll explain that. Next is to represent and convert between 12 and 24-hour time formats. So you might have 1 p.m. or you might have 1300. They're the difference between 12 and 24-hour time formats. So I'll talk about how to convert between them. Solve a variety of problems by calculating elapsed time. So if you've got a time and you add a time to it, it's about working out what that final time is, I guess. Then next is solving problems involving time zones in Australia, making necessary allowances for daylight saving. Next, we've got represent time differences between locations using coordinate universal time. So that's, I guess, your international time zones, working out time differences between them. And finally, solving practical problems using universal coordinated time. Okay, so we're going to jump in and do a few practice on each of these. So the first one here is to convert between seconds, minutes, and hours. So I've done a little flow chart here as to how you can convert between the three of them. So basically, if you're going to a larger time unit, say from seconds to minutes, minutes to hours, or seconds to hours, basically you're going to a larger unit. So that means you're going to have to divide. Because you're going to a larger unit, there's going to be less of them. And it's the exact same in reverse, but you change the divide to a times. You're now timesing when you're going to a smaller unit because there's going to be more of them. Okay, and if you're jumping one across, say from seconds to minutes or minutes to hours, or in reverse, hours to minutes or minutes to seconds, then the thing you times or divide by is 60, because there's 60 seconds in a minute, 60 minutes in an hour. Okay, and then if you're jumping from seconds to hours or hours to seconds, you have to either multiply by 60 twice or divide by 60 twice, depending on which way you're moving. And you can also do that in one step by just dividing by 3600 or timesing by 3600, because 60 squared is 3600, so it's the same thing. So that's how you convert between them. So we're going to do a couple practice examples. So the first one is 7,200 seconds into hours. So we're going from seconds to hours according to the flow chart there. What do? We divide by 3,600. So if I've got 7,200 seconds and if I divide by 3,600, this will give me my result in hours. So if we type that in our calculator, we're going to get 2 hours. Nice, simple, round number. Sometimes you might get 2 point something hours with a decimal point. And then basically so that would mean you've got 2 full hours and a certain part of another hour, but not a full hour, because otherwise it would be up to 3 hours. And then you can work out how many minutes or seconds that decimal point is equivalent to by using the bubble button on your calculator. Next, we've got to convert 36 minutes into seconds. So we're going from minutes to seconds. We're going to a smaller unit, so we multiply, and in this case, we multiply it by 60. Simple as that. So this will give us our answer in seconds. So if we multiply it across, we're going to get 2,160 seconds. And then the final one there is to convert 4.2 hours into minutes. So we're just jumping one across to one smaller unit. So we just multiply by 60 also. So if we do that, we're going to get 252 minutes. Okay, so that is it. And then the other dot point there is to convert between 12-hour and 24-hour time formats. So basically 12-hour time formats run from between 12 a.m. and 12 p.m. p.m. being afternoon, a.m. being morning, and then your 24-hour time formats, they don't need a.m. or p.m. because it's represented, because they go up to numbers larger than 12, such as 13, 14, all the way through to 24 to represent your p.m. So they don't need it. So for example, if we've got 11:36 a.m., you'd represent that in 24-hour time format as that, okay? And you don't need the a.m. or p.m. And if we do a p.m. time, such as 2:06 p.m., if we convert that to 24-hour time formats, it's simply going to be 14:06. It is unnecessary to write the p.m. because the 14 already signifies that it's 24-hour time at, and that it's over, and that it is in PM because it's larger than 12. Okay, so let's keep going. Next, we have another two examples. So based on these 2 points, so solve a variety of practical problems by calculating elapsed time. And then the next is to solve problems involving time zones in Australia, making necessary allowances for daylight saving. So if we look at the first question here, Sam started baking a cake at 3:45 p.m., which takes 85 minutes to bake. When will the cake be ready? So 85 minutes is, the first thing I would do is convert that time into hours. So if we know 60 minutes is in 1 hour, we know that that's going to be equal to 1 hour and 25 minutes. If we convert that 85 minutes, so that 85 is equal to 1 hour and 25 minutes. And then we simply just add it on to 3:45 p.m. So I would do the hour first and then the minute second. So if we add the 1 hour, we're going to get 4:45 p.m. And now if we add another 25 minutes, we're going to get, well, if we add 15 minutes, we get up to 5 o'clock. And then we've got another 10 minutes to add. So that's got to get up to 10 past 5. So it's going to be 5:10 p.m. And that will be your final answer. So that will be when the cake will be ready. The next question there is a flight leaves Brisbane at 11 a.m. and takes 1 hour and 30 minutes to land in Sydney. What time will it land in Sydney, given that Sydney is 1 hour ahead because of daylight saving time? So you might see daylight saving time written as DST. So if first of all, you can take into account the daylight savings at the beginning of the question or at the end of the question. So if we just ignore it now for the meantime and just add on an hour and a half to 11 a.m., we're going to get 12:30 p.m., which has got to be 30 minutes past midday in the afternoon. Then if we take into account the daylight savings, if we add 1 hour to take this into account, that Sydney's 1 hour ahead, we're going to get 1:30 p.m. Or similarly, if we do the daylight savings now at the start of the question, we can now say, okay, if the flight leaves Brisbane at 11 a.m., that's the same as leaving Sydney at 12 p.m., so at midday. Then the flight takes an hour and a half, so now we add 1.5 hours to this, and now we're going to get 1:30 p.m. So they're both the same, whether you take into account the daylight savings at the beginning or end of the problem. But your final answer there is 1:30. And finally, to finish off on these last 2 dot points regarding UTC, I found a 2024 HSC Standard 2 paper. This is question 37, which involves these 2 dot points. So I'll talk you through how to do these. So Sakura will travel from Sydney, who is 10 hours ahead of UTC, to Rio de Janeiro, who is 3 hours behind UTC. So that difference there between 10 and -3 is 13 hours. So that means Sydney is actually 13 hours ahead of Rio. That's what that means. It's not 10 -3 and Sydney 7 hours ahead. You've got to look at the gap as if it were on a number line, as if you had -3 and then 10 over here. That gap is positive 13. So Sydney's got to be 10 hours ahead, or Rio is 13 hours behind of Sydney, whichever you want to think about it as. The flight from Sydney to Rio will take 20 hours. The flight will arrive in Rio at 3 p.m. on Wednesday, 20th of July. On what day and at what time will Sakura leave Sydney? The way I would do this is work out what time the flight would have to leave Rio, so go 20 hours behind time in Rio, and then convert that Rio time to Sydney time by adding 13 hours to it. So if we look at 3 p.m. Wednesday, 20th of July, we're going to go 20 hours back, and that's going to be the time that the flight left Sydney in Rio time. So if we want to take away 20 hours, well, if we just imagine taking away 24 hours, we've got to be 3 p.m. Tuesday, the 19th of July. So that's if we take away 24 hours, but the flight's 20 hours, so we need to take away 20 only. So we've actually got to add 4 hours, and then we would have taken away 20 hours. So if we add 4 hours to this, we're now going to be at 7 p.m. Tuesday, 19th of July, and this is all in Rio time. So what I did from going from here to here is I minus 24 hours, and then what I did was add 4. So in effect, I've minus 20 hours. So that now I know when the flight would have left in Rio time. Now all I've got to do is convert this Rio time to Sydney time. So that's exactly what I'm going to do. And the gap there you can see is 13 as we worked out at the start. So I've got this time in Rio time, but now I need to add 13 hours to it because Sydney is 13 hours ahead. So if I add 12 hours to that time, I'm going to get 8 a.m. Wednesday, the 20th of July. So that's if I add 13 hours, not 12. If I add 13 hours, that 7 p.m., well, if I add 12, will become a 7 a.m. And then the days will tick over to be Wednesday, and this will become 20th, and it'll still be in July. And then you just tick over one more hour as well to make it 13. So therefore, that is the time the flight will leave in Sydney time. So that is the end of these practice questions. Thank you.